Okay, so this is going to be the first problem we've worked. We're going to find the absolute maximum moment in a beam. So as we just talked about, you don't draw the influence line for this. You have a different thing you need to find initially. You need to find the resultant force of the system and where it acts. And then remember, about the center line of the beam, you're going to balance each force with the resultant and look for moments. So first thing to do is find the resultant force. So our resultant force, is just going to be the sum of the two forces, which in this case is 1,200 pounds plus 400 pounds, which I believe is 1,600 pounds. Now, where would that force reside in this system? What I like to do is just draw a little diagram. So I'll have the force on the far left, in this case the 1,200 pound force, and then 8 feet back is the 400 pound force, and then somewhere in there is the resultant force, which is 1,600 pounds, and maybe some distance x1 measured from the front. So what I'm going to do is I'm going to make sure that the moment caused by the real set, in this case the blue colored ones, will be the moment also created by the equivalent set. So I'm going to pick just this front point right under the 1,200. I'll just call it point P. And I'm going to sum moments about P. So about P, what is the moment created by the real forces? Well, the 1,200 passes through P. That creates no moment. The 400 creates negative moment, and it would be 400 pounds times 8 feet. Now, this is not equilibrium. This is just moment. So that would be what? 3,200 pound feet. Also, if I sum moments about the same point, but just considered the equivalent set, then what would I have? I'd have minus 1,600 pounds times a distance of x1. And that should also be equal to 3,200. The effect has to be the same. So if you solve for x1, what do you get? You get 2 feet. So now I know where my resultant load is within my real set. It's going to be 2 feet back from the 1,200. So not equilibrium per se, but equivalent moments about a point. Okay? You guys good with that? So now we're going to apply it. Now, so the absolute maximum moment, if we do case 1, would look something like this. So I'm going to draw the beam. It's 30 feet. I'm going to imagine a center line of the beam. And then we will have my AY and BY reactions. And now I'm going to let my load system come across the beam from the right side to the left side. And I'm going to take the first force and the resultant force, and I'm going to balance them equidistant about the center line. So what would that look like? Well, my 1,200 pound force would be here, and my resultant force would be here. Now, what's the distance between them? x1, which is 2. You split that in half, you get 1 foot and 1 foot. Now, how many feet back do we get to the 400 pound force? Well, if this is 2 feet, what's this part here? 6 feet. So you go 6 feet back, and you should hit the 400 pounds. So that's the scenario we're going to look at. And if this is 1 foot, then the distance from A to here should be what? Well, we split the beam in half, so each side is 15, so this will be 14. So that means we're looking for the moment right here, and I'll call it M1, meaning case 1. So if I want to find the internal moment right there, imagine the structure being cut there. All right, I'm making a cut. And what side of the beam do you want to work? The left side or the right side? The left. So if I'm going to do the left side, I want to find AY. How do I find AY for this structure? Sum the moments at B. So I'm going to sum the moments at B and make sure it's in equilibrium. And when I do that, I now can decide to use the real force system or, not and, or the equivalent system. I like the equivalent system because it's just one force. So what is the moment about B due to the equivalent system? Well, it'll be positive. The force is 1,600 pounds. What's the distance from B to here? Well, half the beam is 15. 1 foot away, this distance is 14. And then AY creates negative moment of a distance of 30. So what's AY? I don't know what that is. 1,600 times 14 divided by 30. Less than 800. Calculator says 747. Anybody else get 747? Yes? Yes? Okay. So now I cut the structure at that point. I just found my AY value. What was it? 747. And I'm looking for the internal moment at that point 1. How do I find that? Yep, just sum the moments at the cut. I've got my internal moment, which is positive. The reaction force 747 creates negative moment times a distance of 14 feet. So what's the moment there? Should be more than that. 747 times 14?
10,000.
Oh, 10,000.
Yeah, that's 10,400.
10,453. And that should be pound feet. And that would be at 14 feet from A. So that's location and value. But we are not done, are we? We have one more check. What would it be? We've got to take the second force and the resultant and balanced in equidistant around the center line. So give me a second to put a page down for this, and we'll do that real quick. So let's start again. I'll draw my beam. We'll call this case 2. We still have a reaction at A and a reaction at B. We've got our center line. So this time I'm going to balance the second force, which was 400 pounds, and the resultant, which was 1600, about the center line. You might remember from the previous problem, the distance between those were 6. So when you balance it about the center line, you're going to get 3 feet and 3 feet. And then, of course, 2 feet in front is the 1,200-pound real load. And remember, since we're balancing this 400-pound force with the resultant, then that's the location that we're trying to find the moment. I'll call that M2. So when I cut the structure there, you want to work the left side or the right side? I think the right side looks easier. So I want to find, this time I want to find By. So I will now sum moments about A, make sure it's in equilibrium. And again, like we talked last time, you can either use the real force system or, not and, or the equivalent system. I'm going to do the equivalent system. So summing about A, the 600-pound force creates negative moment. And what's the distance from A to that center right there? 12 feet. It's 15 minus 3, that's 12 feet. And then By creates positive moment, distance of 30. So what is By? 640 pounds. Okay. So then I'm going to come down and look at the right side. We just found that By was 640. And we're looking for the moment here, M2. And again, from the center line to B is 15 feet, and we know that this is balanced, so it's 3. So again, this little piece of it should be 12 feet. And what's the moment at 2? Well, we'll just sum moments at the cut. Make sure it's in equilibrium. So the internal moment here, with right-hand rule, is negative. The 640-pound reaction force creates positive moment. And it has a moment arm of 12 feet. So what is the moment at 2? 680? So that'll be pound feet. And that's at, from A, that would be 15 and 3. That'd be 18 feet from A. So again, location and value. But flipping back, what was our previous one? I think it was 10,000. So the max moment at 2 would be 10,453. And that would be pound feet at 14 feet from A. And that is the solution to the problem. Magnitude and location. Yes?
Wouldn't that be like, isn't that max moment just like on the whole beam?
It's the maximum moment in the beam due to this load. And that load scenario moving.
Okay.
All right? So this whole last section we've talked about has been due to moving loads. Yes?
So why is it M2 max?
Why is it what?
Why is it M2 max and not M1 max? It was the first case that was max.
Oh, yeah. Sorry. You're correct. I'll make it a big Roman numeral 1.
Why would it be M1 max? Why would it just be M max?
It would be M max.
Okay.
The one is gratuitous. I'll just get rid of it completely. I'll make a big black spot. So this is max, black spot, max. Moment at the black spot, max. This is the international symbol for absolute.
Okay.
I'm going to add that to all the emojis on your phone. If you send somebody a big squiggly black blob, they'll know that that means absolute. That's right. It's a black hole. It's absolute. Any questions that don't involve astrophysics or iconography? All right. And this brings us